Last week, I don't remember which lesson it was. I think it was 1.3. We talked about inductive reasoning. Do we remember what inductive reasoning is? Remember what I mean by conjecture? Remember making those? If I give you 1, 3, 5, 7, that is our sequence. That's arithmetic sequence with numbers, right? How would we find a pattern? Yep, 1 to 3, we're adding 2, 3 to 5. Add 2, 5 to 7. Add 2, ringing a bell. Okay, this is our inductive reasoning we talked about. So my conjecture remembers the pattern we find, which is adding 2. So then my next number would be 9. Next number would be 11. Okay, do we remember geometric reasoning? Or geometric sequences? What? Pictures and shapes, right? So that's inductive reasoning. With inductive reasoning, we're finding our own pattern. Okay, today we're talking about deductive reasoning. With deductive reasoning, the answer is in the problem for you. You don't have to come up with patterns. Okay, so let's just jump right into it and what I mean by that. Okay, so using deductive reasoning, you're given an if-then statement, and the if is the hypothesis, the then is the conclusion. Well, if that is true, then you conclude that the conclusion is true. Okay, so jumping into example 1 on your notes, it says, given that a conditional, what does it mean by conditional? Say it louder if you said it. Conditional means if-then statement. Yep. So given that the if-then statement and its hypothesis, what part of the if-then is the hypothesis? The if, yep. So given the if-then and the if is true, what can we determine about the conclusion? What's the conclusion? The then. What can we determine about the conclusion? If the rest of it is true, is the conclusion true? Yes. Okay. So with looking at this example, law of detachment. Okay, with law of detachment, you get one if-then statement, and you can get an answer from that statement. Okay, so it says, if P then Q, then we know Q is true. We're used to that, right? That's our original if-then statement. Looking at this example right here, it's not in your notes yet. It says, if Alicia scores 85% or greater on her test, then she will earn an A as her final grade. That's my if-then statement. And then it says, Alicia scores 89% on her test. What can we logically conclude? She got an A, right? It says if she scores greater than 85, well, she got an 89, so we know that she got an A for her final grade. What if it was 84? She did not get an A. Okay, so that's what we're getting from the if-then statement. It's going to give you the if-then statement, and it's going to say a statement about that, and then it's going to ask what you can conclude from that statement. Okay, let's look at one more. If point D is in the interior of ABC, so what it just did, it described this picture right here. Then the measure of ABC equals the measure of ABD and DBC. What can you logically conclude about the measure of ABC? So it gave us this if-then statement right here. How can we figure out what the measure of ABC is? How can we figure it out? Say it louder. Add them together, right? Right here in the if-then statement, it told you what to do, right? Told you to add it together. So you would use that formula to figure out what ABC is. Okay, so sometimes in the if-then statements, it'll give you a formula. You're probably going to use that formula to find your conclusion. Okay? Go ahead and try 2A and B. You're trying to make conclusions of what it's asking you. All right, let's talk about it. Number 1, or A, if two angles are congruent, then the measures of the two angles are equal to each other. That's our if-then statement. Okay? It says the statement they want you to decipher between is angle 1 is congruent to angle 2. So what can we conclude about the measures of the angles? They're the same, right? Where did you get that from?
The sentences.
Right, the sentences tell you what it is, right? It's told us that 1 and 2 are congruent. So if we know that their measures are equal or the same. Okay? So you're not doing any math, okay? You're just getting the answer from the if-then statement. Okay? B, it says, if you finish the race in under 30 minutes, then you win a prize. If you finished in the race in 26 minutes, what can you conclude? You win a prize. What if I finished in 30 minutes? No prize. Why not? It says under 30 minutes. Okay. Questions about law of detachment. What it means by law of detachment, you're getting the answer from the if-then statement. Okay? Law of syllogism. Okay? Talk with someone sitting next to you what you notice about this statement right here. What are the connections you can make? Okay, what is the connection? What's the connection you guys are making? So what this says, if P then Q, and if Q then R, then we know P and R is true. Does that make sense why that's true? No. Okay, because here, P and Q, this is our original if-then statement. Do you agree? So this is one if-then statement. Here is another separate if-then statement. What's the similar in both of those? They both have Q, right? So from the first equation, we know Q is true. So then in the second equation, if Q is true, we know R is true. So that's why we can make the connection between P and R. Okay, since they both have Q, we know those are similar, so we can make the direct connection that P and R are also true. Okay, we're going to look at an example. It's okay if that doesn't make sense. Let's look at this one right here. So with law of syllogism, you're going to have two if-then statements. Your goal is to make one from the two. Okay, so our first one here, we have if Kenji plays the trumpet, then he plays a brass instrument. That's the first one. Second one's right here. If he plays a brass instrument, he is a member of the marching band. You want to find the statement in both of those that is the same. Do you see a similar statement? The brass instrument, right? We're going to take out that similar saying. And then the rest is our new if-then statement. So our new if statement is if Kenji plays the trumpet, then he is a member of the marching band. Does that make sense how I made that? Okay, so you have two if-then statements, and we're making it down to one. Okay, so law of syllogism, you start with two if-then statements. You are making one if-then statement by crossing out what they have in common. Okay, finding the connection. Let's look at one more together. This one, it says if... Here's my first one. If points A, B, and C are collinear. First of all, what's that mean? On the same line. Yep. Then BA and BC are opposite rays. And then the second one here. If BA and BC are opposite rays, then AB plus BC equals AC. What can we conclude? When it asks you that, we are trying to make one if-then statement. So what do both of those sentences have in common? There's one statement that both of them have. The opposite ray statement, I agree. So I'm going to take it out. And then do we have a new if-then statement? Now, if points A, B, and C are collinear, then AB plus BC equals AC. Okay? On A, here's my first one. If an integer is divisible by 6, then it is divisible by 2. Here's my second one. If an integer is divisible by 2, then it is an even number. First, what do they have in common? Divisible by 2. If it helps, take it out. What is my new if-then statement? Then it is an even number. Yep. So remember, you're taking out what you have in common, and you're making one if-then statement. Okay? B is a little trickier. Here's my first one. If it is a holiday, then you do not have to go to school. Here's my second one. If it is Labor Day, then it is a holiday. They have the holiday statement in common. I agree. What would my new if-then statement be? Good. If it is Labor Day, then you do not have to go to school. Why can I not say if you do not go to school, then it is Labor Day? What'd you say? What if you're sick? Okay, and that's not true, right? That's not always true because you could be sick or it wouldn't have to be Labor Day. Does that make sense? This one, it did already give you the if and the then. Okay, so remember when you write if-then statements, you want them to make sense. Okay? 1 to 5 on syllogism. Syllogism is the one you're taking two if-thens and you're turning it into one. Okay, do you guys like this better than inductive reasoning? You should. Yep. Okay. One more thing. On number 4, it kind of puts law of detachment and I forgot how to say that word, syllogism into one problem. Okay, so looking at this one, on the first one, if a quadrilateral has 4 right angles, I want you to write that as one if-then statement. So use the law of syllogism on this part right here, that first part. So again, when I say use law of syllogism, what are you doing? What? Talk louder. Make it 1, right? You're going from 2 to 1. Find what they have in common, and then put the rest together. Okay, what do they have in common? Okay, I hear some, they have quadrilateral, but what they're saying is it the same? Like this one says the quadrilateral has 4 right angles, and this one says a rectangle. Is that the same? Yep, the rectangle sentence is the same. Yep. So take out rectangle. What is my new if-then statement? Yep, if a quadrilateral has 4 right angles, then it has 2 sets of parallel sides. Okay, you just use law of syllogism. Now right here it asks you a statement. A polygon has 4 sides and 4 right angles. What conclusion can you draw? If a polygon has 4 sides and 4 right angles, there is more than one answer to this. What can you conclude? It's a square. So what they used in this one, it's a quadrilateral. What else can you say? Rectangle. What else? Yep, because you said it's a quadrilateral, right? Okay, so that would imply that it would have 2 sets of parallel sides. Okay, hint, when you do both of them at the same time, don't forget what you crossed out in the beginning. Does that make sense? Because that still applies to what's happening. Okay, so don't forget what you cross out. Questions about law of detachment or law of syllogism? Go ahead and flip to the back of your notes. On number 2, the error analysis. Dakota was using the law of detachment. Well, its if-then statement is if my favorite team wins more than 55 games, then they win the championship. What he got from that is that my team won the championship, so they won more than 55 games. What's wrong with that? What's the hypothesis? Right, they have to win the games first, so she wrote it backwards. Does that make sense? The 55 games has to come before they win the championship. Okay, so that was what she did wrong using the law of detachment. On number 3, what are the differences between law of detachment and law of syllogism? What's the difference? How many statements does detachment have? 1. How many statements does syllogism have? 2. Yep. I'm skipping 4. We're jumping over to 5, 6, 7, and 8. Go solve those 4 problems. You're either going to use detachment or syllogism. You have to determine which one. Let's talk about these together. Number 1, if you have a temperature above 100.4, then you have a fever. Mario has a temperature of 101.2. What can you conclude? He has a fever. Good. What law did you use? Detachment. Yep. You used detachment because you got the answer directly from the statement. Okay. Number 2, if points A, B, and C are collinear with B being between A and C, then AB plus BC equals AC. What can you conclude about AC from this picture right here? Hint, if you don't know, look at the then. How can I use the then? Apply it to this picture. Yep, 3x plus 5x minus 3 equals AC. So we just plugged in values to the then statement. Okay, so if you're struggling with how to use law of detachment, you're going to look at that then statement. Okay. Questions about those? What rule did we use on that one? Detachment. Yep. Number 7 says if you eat too much, you can get a stomach ache. If you get a stomach ache, you want to rest. What law are we using? Syllogism. Why do you know you're using syllogism? Because there's 2 of them. What do they have in common? Stomach ache.
It says use the law of syllogism. Yeah.
Oh, sorry. Good job. What does it say? What's our new one? Yep. And then number 4, we're using law of syllogism, everybody, because it tells you. I didn't see that. What do they have in common? Numbers are even. Okay. What is my new if-then statement?
Two numbers are odd.
There you go. Yep. If 2 numbers are odd, then the sum is divisible by 2. Good. Questions on detachment or syllogism? Okay.